So we're going to continue on unit 2. So write unit 2, lesson 7. And here we're going to speak about functional groups. Functional groups. It is very important, this lesson here. It is very, very important for chemistry, for biology, to understand how the molecules behave. Because each molecule, it has a group, functional group. So first here, introduction. I'm going to start by the halides. We're going to start by halides, organic halides. To start by organic halides. Organic halide. So what are organic halides? Organic halides are alkanes or hydrocarbons with halides. What are the halides? So I'm going to go to here. So the halides, what are the halides? You have fluorine, chlorine, bromine, iodine, etc. This is the halides. And the organic halides, they are carbon, hydrogen, and chlorines and halides. So I'm going to take some examples. So naming organic halides. For example, say I have this one here, CH3, CH2, CH2, Cl here, Cl here, CH, CH3, CH3. Okay, so again, we went through this ones here. We take the biggest one, 1, 2, 3, 4, 5, 6, so it will be hexane, because there is no double bonding, there is no triple bonding, so hexane. And I have to number my carbons that I have the least numbers in the side, in the side chains. I have 3 side chains. This one, it is chlorine, so we're going to write it chloro. So what we say, we say fluoro, chloro, chloro, bromo, bromine, bromo, etc. So for example here, what we will have, I have a chloro here, I have a chloro here, and I have a methyl. So I have to label my carbons. I'm going to label them on this side, 1, 2, 3, 4, 5, 6, to have the list numbers. And again, what I'm going to do, I have to start with what? By chloro, because C comes before M. How many chloro I have? I have 2. I have one in the position 3 and the other one in position 3. So it will be 3, 3, chloro, chloro. The methyl, it is in the position 2. Dichloro, excuse me, dichloro, because I have 2 chloro. Dichloro, 3, 3, dichloro. And I have methyl in the position 2, 2, methyl, hexane. This is the name. Now, I'm going to go to another type of questions. For example, here, draw a structure of, they gave me the name 1 bromo dichloro bromo 2, 5 dichloro benzene, chlorobenzene. So here again, I have to divide my name to its subtract. I have 1 bromo, 2 dichloro, benzene. So I have a ring of benzene. I have to put the ring of benzene. I'm going to put it here. This is the ring of the benzene. I can start with 1 carbon. I can start it, for example, here. This is 1, 2, 3, 4, 5, 6. I can go other side if I want. And he told me to put a bromine in the position 1. So I'm going to put a bromine here. Br. And he told me put dichloro, so 2 chlorine, 1 in the position 2. So I'm going to have 1 here and 1 in the position 5. It will be here. So this is. What are the properties for organic halides? The organic halides are polar molecules. What does it mean? It means that you will have a higher melting and boiling points comparing to the alkanes. So properties organic halides are polar. So what does it mean? The forces, the intermolecular forces are dipole. They have dipole intermolecular forces. So with these dipole molecular forces, the boiling and melting points, the boiling and the melting points of the halides are greater compared to the alkane, compared to the alkane with the same carbons, Yeah, it's only because we have more forces, dipole. The alkanes, we said, they are not polar. Okay, alcenes are not polar. Now synthesis. How we can synthesize the synthesis of organic halides? How we can synthesize them? Yeah, we can synthesize them. We can do it by what? By addition or substitution. We saw that addition in alkenes, substitution in alkynes, and we spoke about these 2 reactions. Okay, here I'm going to stop for the organic halides, and there is only one thing that I'm going to say. For example, usually now in chemistry we call R or radicals. So I'm going to write it here. Vocabulary. It is very important. Vocabulary called radical. We noted R. We noted the radical R. All organic molecule with only carbons and hydrogens. For example, that you are going to understand. For For example, say I have this one here, carbon, 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 and I have here a chlorine, for example. I have here CH3, CH2, CH2, CH, CH3. So I'm going to write it clearly that you can. CH3, CH2, CH2, CH, CH3, and I have here chlorine, for example. So all this one here, we call it R. All that stuff, we call it a radical, and we're going to represent it by R. In the end, this molecule will be RCl. This is notation. When you are going to say it, that R here replaces all this chain, for example, here. Why we represent? Because we know the R, it is carbons and hydrogens, and we know the carbons and hydrogens are not polar. We have a lot of information about it. So everything now, the function of this molecule, it is here, because it is the only one that is polar. All the other bounded are not polar. We went through that in the previous videos, so lessons. So that's why usually halides, we put them like that, R, X, and X now can be fluorine, chlorine, bromine. This is halides. R again, it is this stuff. Okay, I'm going to stop here now.